Good afternoon, good evening, or good morning, depending on where you are in the world. Would like to present to you three articles of interest. And before I do that, we'd like to let you know this is for review, informational, and educational purposes. It's not to take the credit for the intellectual property of the article. The full credit to the intellectual property of this article goes to Tom's Hardware, which is the publisher, and the story by Ash Hill. The headline reads, "This pocket-sized Raspberry Pi 5 PC is portable and modular." And ahead of you see a picture of such device. Looks really nice. Looks really good. Caption reads, "A pocket-sized Raspberry Pi 5 portable and modular. Copyright Soul Circuit." Looks like it's what it says here, if I have that right. Soul Circuit. Yes, that's right. The Raspberry Pi is an excellent board for building custom mini PCs that've got a lot of flexibility when it comes to cases, size, and support for external peripherals. That's why it came as no surprise that the team over at Soul Circuit decided to create its own ultimate modular experience with the Raspberry Pi 5 base project. It's PILET. And we have a related video here that's embedded onto YouTube that you'll be able to watch upon publishing of this review. And the headline reads, or it's entitled Pilot, P-I-L-E-T, Pi 5 Power Tablet / Cyberdeck with 7-hour battery life. Overall performance demo. So go ahead and take a look at that. I will myself look at that later after I finish this review. Now, this isn't the first Raspberry Pi powered modular setup that we've encountered. In the past, we've discovered this cool RP2040 modular macro pad and used magnets to snap add-ons into place. Instead of a macro pod, however, the Pilot is a fully on pocket PC complete with modules for game controller input and keyboards. However, it's important to make note that there's still work in progress, so we don't know exactly what the final build will be like. Some design aspects are subject to change, but the project's root stands out as a remarkable and fun experience. So far, Soul Circuit has put together, it should be a space between the T of Soul Circuit and has, H and has. Anyway, has put together an engineering sample with plans to aim for a budget for under $200 per device. Ooh, nice. And there is a slide of this, how it would look like. It actually looks quite good. I like the fact that you have a touchpad and a roller here. You can use your finger. You have the arrows, and the touchpad is basically like a mouse, and you have a keyboard here. Now the Pi in this project is a Raspberry Pi 5, which is powered by a couple of 8,000 milliamp hour batteries and has an expected battery life of around 7 hours. And the author says, "We're not entirely sure what the case material is, but Pilot website confirmed the metal back with the fan help with passive cooling also has NVMe SSD for storage and can support a Halio 8L module for AI capability." In this example, videos and screenshots we see with the Raspberry Pi running Raspberry Pi OS, but there's no reason you can't spruce things up with Kali Linux or RetroPie image. On one of the project goals is to implement open source tools for maximum flexibility, but details on what entails are scarce right now. In the meantime, you can sign up on the website to get updates directly from the team at Soul Circuit. If you want to see the Raspberry Pi project in action, visit the official Pilot website where you'd find links to some neat demo videos. And the author would like to point out that this article may contain affiliate links that Microsoft and or the publisher may receive a commission from if you buy a product or service through those links, which I think is fair. They're doing a service to refer business, that's fair. Just in my opinion. Okay, let's get to our second article here out of three. There's three of them, so this is the second one. And before I do that, I would like to let you know this is for review. informational, and educational purposes. It's not to take the credit for the intellectual property of the article. The full credit for the intellectual property article goes to the publisher, which in this case is Interesting Engineering, and the story by Jijo Malalali. Malalalo, if I pronounced his name right. Headline reads, Metalsmith. Versatile AI robots create custom metal parts for NASA. Oops. Let me just close that. People like to send me messages on Instagram when I'm not available here. Oops, there we go, sorry. Why is that not closed? I should have that closed there. Okay, cool. So it popped up a couple times, whatever. So yeah, so let me say that again because I was just interrupted. Metalsmith. Versatile AI robots create custom metal parts for NASA missions. Story by Jijo Malalo. Ahead of you, you see a picture of this like robotic arm working on this project, this whatever metal part. Metalsmith. Versatile AI robots create custom metal parts for NASA missions. Machina Labs is helping NASA with the next generation of manufacturing with new robotic blacksmith army. And Robotic Craftsman platform is a versatile manufacturing system featuring 7-axis robots that can quickly load sheets, set up parts, and use advanced AI to manage and control processes. The robots instantly switch tools and sensors to handle various tasks such as shaping, scanning, and trimming different materials. The system is regularly updated to enhance and add new functions. The versatility of the robotic metal workers allows for the creation of custom parts that would be difficult to produce otherwise. These include donut-shaped fuel tanks, which NASA has been interested in for decades. Quote, innovative technologies that use sheet metal feedstock have brought up applications in NASA as structural hardware, enclosures, instruments, and robotics. Among others, but also for use in low-gravity manufacturing such as Earth orbit or lunar surface, says NASA in a statement. Efficient metal processing. Traditionally, resource limitations and versatility has been taken into consideration while designing ground-based manufacturing processes. Heavy single-purpose machinery is frequently employed to complete a single task and extensive series of tasks. They are not entirely autonomous because they require expert staff to ensure quality and continue operating. All of them are luxury items that are unaffordable in space. Nonetheless, NASA's ability to extend its presence into deep space successfully depends on both the procedures themselves and the expertise in those production methods. And ahead of you see a related video entitled Related Video, a Robot at the Wheel, as per DW. And you'll be able to watch this video upon the publishing of this review. However, because sheet metal components are widely utilized in many applications, manufacturing them makes deep space travel possible. Here, the goal is to simplify as known on-the-ground manufacturing process so that NASA can use it for both in-orbit and on-the-ground applications. Aiming to find more efficient solution, Machina combines cutting-edge AI and robotics revolutionize the sheet metal industry through its proprietary roboforming process and delivers finished products in days rather than months or years. This provides customers with significant time to market advantages and helps address supply chain challenges in the defense, aerospace, and automotive sectors, including critical components like structural sustainment parts, propulsion, tanks, and tooling. By integrating precise industrial robotics, AI-driven process control, and interchangeable tools with single-cell roboforming, efficiently shapes sheet metal into large, complex parts. This approach eliminates the need for costly molds and dies, which are typically expensive and time-consuming to produce traditional methods. AI-driven fabrication. Machina Lab collaborated with NASA to provide a flexible system for forming complex parts and reworking for repairing existing ones using an integrated metrology system for control and analysis. Phase 2 of the project looked into enhanced system autonomy with advanced controls and data-driven insights, prototype various tank sizes and shapes, and collaborate with Michaud Assembly Facility on a large toroidal tank for NASA. Toroidal tank lower the vehicle's center of gravity compared to the spherical or pill-shaped tanks. Machina trains these robots using proprietary physics-based simulations, as existing software is too slow. The robots undergo iterations with human guidance based on real-world data, effectively simulating metal behavior under pressure. According to IEEE Spectrum, despite challenges such as simulating tool adherence in the material, the robots are gathering extensive empirical data, allowing Machina to make significant strides towards full autonomy and process improvement. And the author concludes by saying, benefits include enabling space manufacturing, producing lightweight parts for NASA, and repurposing materials for on-orbit servicing, assembly, and manufacturing, that is OSAM. The robotic cell will also serve multiple industries, allowing for rapid design iteration, reduced costs, and high-performance part fabrication. All right. So what do you think of this? You think it's pretty interesting? You think it has lots of potential? All right. I'll leave that up to you. We'll look at a third and final article of the review. Now, as usual, before I do that, I would like to let you know this is for review, informational, and educational purposes. It's not to take the credit for the intellectual property of the article. The full credit for the intellectual property of the article goes to the publisher, which in this case is Interesting Engineering, and the story by Kapil Kajal. Headline reads, World's first petahertz-frequency mixer advances ultra-fast communications tech. And ahead of you is actually a picture of this integrated circuit, otherwise known as a computer chip, or IC, and some artistry rendering of it. Well, the caption reads, World's first petahertz-frequency mixer advances to ultra-fast, that is, advances ultra-fast communications tech. During a phone call, the human voice is converted to electronic signals, transmitted and heard clearly on the other end. The process enabling the shifting of signal frequencies is called frequency mixing and is essential for communication technologies like radio and Wi-Fi. Frequency mixers are crucial components like electronic devices operating at billions, that is gigahertz, GHz, which stands for gigahertz, or trillions, that is THz, which is means trillions of hertz or terahertz of times per second. Imagine a frequency mixer that operates at quadrillion. This is PHz. This is petahertz. So each time is 1,000 times more, by the way. This is times per second, enabling transmission and processing of significantly larger amounts of information at much higher speeds. So obviously the rate of communication is much more efficient. MIT has demonstrated a new light-wave electronic mixer at petahertz scale frequency, a first step towards making communication technology faster. It also progresses research toward developing new miniaturized light-wave electronic circuitry capable of handling optical signals directly at the nanoscale. Ultra-fast oscillations. Petahertz frequency mixers would also allow humans to shift signals up to optical frequencies and back down to more conventional electronic frequencies, enabling the transmission and processing of vastly larger amounts of information at many times higher speed. This leap in speed isn't just doing things faster, but enabling entirely new capabilities. Lightwave electronics, or petahertz electronics, is an emerging field that aims to integrate optical electronic systems at incredibly high speeds, leveraging ultra-fast oscillations of light fields. The key idea is to harness the electric field of light waves, which oscillate on sub-femtosecond timescales to drive electronic processes directly. This allows for the processing and manipulating information at speeds far beyond what is possible with current electronic technologies. A petahertz electronic mixer, in combination with other petahertz circuitry, would allow us to process and analyze vast amounts of information in real time and transfer larger amounts of data over unprecedented speeds. Nanotechnology. In the 1970s, scientists began exploring ways to extend electronic frequency mixing into the terahertz range using diodes. And if you don't know what a diode is a electronic part that controls the direction of current flow. While these early efforts showed promise, progress stalled for decades. Recently, however, advances in nanotechnology has reignited this area of research. Researchers discovered that teeny structures like nanometer length scale needle tips and plasmonic antenna excuse me, could function similarly up to those early diodes at much higher frequencies. A recent open access study published at the Sciences Advances by Matthew Young, Matthew Young, Lu Ting Chu, Marco Turchet, Felix Rutzowski, Carl K. Berggren, and Philip D. Keithley at MIT has demonstrated a significant step forward. They developed an electronic frequency mixer for signal detection that operates beyond the 0.350 petahertz using only nano antennae. These nano antennae have mixed different frequencies of light, enabling analysis of signals oscillating orders of magnitude faster than the fastest accessible to conventional electronics. Such petahertz electronic devices could enable developments that would ultimately revolutionize fields that require precise analysis of extremely fast optical signals, such as spectroscopy and imaging, where capturing femtosecond scale dynamics is crucial, which is a femtosecond is 1/1,000,000th of 1/1000,000th of a second. So billion is 9 zeros, and million is 6 zeros. So that was 15 zeros. 1 over, basically, or 1 times 10 to the negative 15, basically. Or 1 over, and then it's 0, 15. It's 15 zeros, then a 1, I believe. That is a femtosecond. Excuse me, 1 over 15 zeros, yeah. The team study highlights the use of nano antenna networks to create a broadband on-chip electronic optical frequency mixer. This innovative approach allows the accurate readout of optical waveforms spanning more than 1 octave of bandwidth. Wavelengths. Importantly, the process of commercial turnkey laser that can be purchased off the shelf rather than highly customized laser. While optical frequency mixing is possible using nonlinear materials, the process is purely optical, that is, converts light input to light output at a new frequency. Furthermore, the materials have to be many thick wavelengths, limiting the device size to the micrometer scale. A micrometer is 1/1,000,000th of a meter. Okay. Well, this study is focused on characterizing light pulses of different frequencies. The researchers envision that similar devices will enable the construction of circuits using light waves. With bandwidth spanning multiple octaves, the device could provide new ways to investigate ultra-fast light-matter interactions, accelerating advancements in ultra-fast source technologies. This work not only pushes the boundaries of what is possible in optical signal processing, but also bridges the gap between the fields of electronics and optics. By connecting these two important research areas, the study paves the way for new technologies and applications in fields like spectroscopy, imaging, and communications, ultimately advancing our ability to explore and manipulate the ultra-fast dynamics of light. Let me get some water here. Actually, I don't have any more water. It's okay. What do you think of that article? Was that interesting? Does that hold promise? What is your opinion on that? Well, I'd like to take this time to thank you for watching this article, as you could be watching any other science or technology news, but you watched mine, so I certainly do appreciate it. As this did provide value to you, to be up to date with the news, especially with science and technology, what I'd like you to do is please click like on the video. That way I'll be pushing the algorithm and more people will be able to view it and enjoy it. If you haven't already, please click the subscribe button. That way you'll have access to all the content on my channel, as I certainly do have a variety of content on this channel for you to enjoy and benefit from. Also, if you haven't already, please click the bell button. That way you'll be notified of all my future videos. That way, when a new video comes out, you'll be notified accordingly and you won't miss any of my new videos as they do come out. Excuse me. So I'd like to wish you a great day wherever you are in the world. Take care, and I'll talk to you next time. Bye for now.